Good morning. We're going to start our Unit 3 notes, which is based on collecting data. So I want to kind of go back to the very beginning. And by the way, these notes begin on page 3 today. And we're going to be briefly going through page 3 and 11, and then we continue with further notes on other segments. So basically, we needed to go back to the very, very beginning and talk about what statistics is. And statistics is the study of how to collect, organize, display, describe, and analyze data from a sample in order to make generalizations about a population. Okay, well, we've already displayed and described data, but now we're going to learn how to collect data, which is probably the most difficult thing in all of statistics. Not in the course, in fact, it's very interesting in the course, but practically carrying it out, we find out that it's a difficult topic to do. Now, it's really important that we collect good data in order to make a generalization. In other words, we're going to use a sample to mirror or look like the population, or we're going to use a sample in order to make generalizations about the population. So if our sample looks like the population, we're going to have a good estimate of the population. If our sample doesn't look like the population of interest, then whatever we say is not going to be accurate. So I need to go back and talk about some terms. Population versus sample. Population is the group of interest. It can be any group, and then in this particular year of an election year, the population is US voters, and we want to know, one of the things that I know we want to know is what percentage of the voters are going to support a particular candidate, all right? Well, that population of people who actually are going to vote, we want to know what they're going to do. If we actually knew the population proportion, or the proportion of people who are going to vote, or the number of people, we'd have a parameter. So a parameter is a measurement of the population, but we rarely ever have a parameter. That's rarely known because populations tend to be large. So we have that, and if we did know it, there once again would be no need for this course. A census, on the other hand, is a way to get that information from a population. Now, a census is, and we're actually conducting, this is a census year, and we actually go around and knock on all the doors or send mailers or emails, etc. And we try to collect the data from every individual in the United States so that we know something about them. We know how many they are. We know about their income. We know about their ethnicity, etc. We know where they live so we can proportion representatives appropriately. All right? But census, unfortunately, are really difficult to carry out. Now, if you can carry it out, that's great. And when the U.S. carries out a census, and this is further down on the page, we have found out that they're very inaccurate when they've carried it out because of such a large population. In 2000, this 2000 census, it was estimated that they missed over 6.4 million Americans. However, there was an overcount of Americans by 36,000. And the question is, how in the world did that happen? That you missed 6.4 million, but then you overcounted by 36,000? And the answer is simple. Some people got counted more than once. That's how difficult this is to carry out. And they spent $13 billion in 2010 to do it, which is approximately $42 per person. That's a lot of money just to count numbers. I'm just saying. Okay, so so that's one time a census is really difficult to carry out. If you're trying to do a census, you want to know how many bass are in a particular lake. That'd be really difficult to do without draining the lake, and in which case you drain the lake, we know the answer, how many bass in it? None, because they're all dead, and there's no lake. So obviously, once again, very difficult to carry out in some instances. However, if I wanted to know the average of the class, I can just go take everyone's grade, add them up, and take the average. That time a census does make sense, and so I don't need sampling techniques. So what is a sample? And we're going to move on to page 11 at this point and move towards the middle of the page. Well, a sample is a portion of the population. So it's a smaller subset of the population. It could be a sample of one or two, actually, to a very large sample. And the idea is that the sample would look like the population. And from the sample, we take a statistic, and that statistic is an estimate of the population. But it's really good. It's important to collect a good sample. And here's what I mean. If I were to go around, there's multiple ways to collect a sample. And every year I always talk about the same thing, and that is about collecting a theme song for Reagan students. And I've joked that this year I think the theme song should be I Will Survive by Gloria Gaynor, which is a great song, don't get me wrong, but mainly it's because I will survive because it's COVID-19. And not that students are sitting together in a lunchroom right now, but you remember when they were last year, and I could go ask 25 students that are sitting together in a lunchroom what they thought. And the problem is, if they're sitting together, they're probably friends or friendly. And so that means they're going to have similar tastes and likes. They're not going to be all the same, but they're going to be similar. As such, if I just sample those 25, which would have been really convenient, if I just sample those 25 students, it's not representative of the entire school. It's only representative of that friend group. So probably not a good idea to choose. And then if I say, hey, well, I want to get a representative group that they aren't necessarily friends, maybe I ask my freshman advisory, and real quickly we understand that that's a bad choice because I'm only representing freshmen and the sophomores, juniors, and seniors are left out. How about this? I could go to the teachers' lounge because from there there's freshman representatives from freshman classes, sophomores, juniors, and seniors. But once again, as someone once said, the teachers' lounge is going to choose old people and old music, which I think is a wrong thing to say, but nonetheless, that's what they're going to choose. And we didn't represent the students. We only represented the teachers. So if I wanted to make sure students were represented, I could try the PTA because we all know that that's populated by parents, and so that represents the students. But the answer is no, it really doesn't. It will provide it really only provides the Stone Oak mom representative, which, I don't know that students want to rock out with Stone Oak moms, but maybe so. Okay, so obviously choosing a good sample is important, and we're going to talk about that in a later video. And so that's, I guess, the real question. What makes a good sample? Well, a good sample looks like the population. It looks like a small version of the population. In other words, it contains the major elements of the population. I always like to use the idea of the car. If you look out the back windshield, you see a ton of stuff, whatever you're seeing, all right? However, when you look through the rear view mirror, you see the same image, only smaller. Some of the details have sort of gone away because the image is smaller, but the image looks the same. And so we would say that that image looks like the population, and so it would be a good sample. It's not the entire population, obviously, but it looks like the population. So, in summary, we collect data to make generalizations about the population. It'd be nice to be able to do a census where we know the parameter, but we rarely do, so we have to use a sample to estimate things about the parameter. The sample values that we collect are data, but if I was looking at the proportion of the people supporting a candidate, that would be a sample statistic. So we use a statistic to estimate the population proportion. So populations have parameters. Parameters are measurement of the population. Samples have statistics. Statistics are measurement of the sample. And we use statistics to estimate parameters, all right? So population and proportion, sample, and statistic.